Right, okay. Hello everyone. What we are going to do today is the Nylon 610 rope trick, and I've got my sixth form class, my year 13s. They're all going to say hi.
Hi.
But they're not appearing on camera. I do have to keep my voice up at the moment as well because I am conscious of the fact that I've got a fume cupboard on behind me as well, so hopefully you can hear me. Right, okay, so Nylon 610 rope trick. I'm going to read out the instructions. This is applicable to polymer chemistry, so if you are doing polymers in A-level or polymers in GCSE, this is a really neat demonstration that I've got for you today. What you're essentially going to see is these two liquids added to a small beaker, and we're then going to be able to form polymer at what's called the interface. The interface is where the two liquids meet. They're not actually miscible. Miscible means that they can mix, but these are going to be immiscible. And ideally, according to the instructions, we will be able to get 10 to 15 feet of nylon. I'm going to have to try and figure out whether we actually do. Safety goggles, gloves, because these chemicals are really horrendous for us to deal with. And I've got my lab coat / lab apron, so I'm ready to go. This is going to be performed in a very well ventilated area. So we're going to open the windows over there. So one of my year 13 is now opening all of the windows. We've also got a chemical fume hood. We're actually using relatively small quantities, and once it's actually added together, we should be able to then place it out over here and start the separation. That's pretty okay. Now, one of these, which is called semicoyl chloride, I'm going to zoom in for one of the cameras here. Semicoyl chloride is toxic and can be absorbed through the skin, so we have to be very careful with this one. The other liquid that we've got is 1,6-hexane diamine solution, and it's this one that we're going to start off with first. So the instructions are as follows. We're going to add 5 milliliters in the fume hood of 1,6-hexane diamine solution to a small beaker. Okay. Now, in order to do that, I've actually got some syringes here. Okay, so there's my syringe, and these are 1 milliliter. I should actually have 5 milliliters, but I'll use these to top it up. So I'll pour them out, and then just to top up to a 5 milliliter mark. Using my sorry. You actually turn off. Keep filming. Oh, it gives me a chance to get the milliliters. You can pause. So here we have 5 milliliter syringes. Just going to open those up, make sure that they are. I'm going to put them out in different areas so that I can keep things organised. We've got Ruba in the background. Hello, Ruba. Ruba's our fantastic technician. She's been helping organise everything. So if I need to adjust, I've got some 1 milliliter syringes, but okay, right, so I'm just going to spread everything out so I know that it is all organised. So this is the semicoyl chloride. That's something that we need to be really cautious on. I'm just going to put the wrap there and put the wrap there as well. This is the small beaker. Okay, so in a moment what I will do is I will start to add them. I'll give you a chance to have a look at it as well. Come with me. Okay, so what we're going to do is we're going to start off with our 1,6-hexane diamine solution. I've got my 1 ml syringe here because earlier we found out that the bottleneck was not wide enough, so I just need to do this 5 times. I'll try and do this as quickly as possible. So there's one. You can see that it is a colourless solution. So that's 2. Try and move my hands out of the way to give you something interesting to see. 3. That's 4. And that's 5. You can actually see, hopefully you're zooming in to that. You can actually see that it is a colourless liquid. Seems quite gloopy. Looks harmless, but is very, very dangerous. Okay. And now what I'm going to do is I'm going to slowly add 5 milliliters of our other reagent. So this is 5 milliliters. Now what I'm going to do is I'm going to add it very slowly to the top, and the trick with this is not to allow it to mix. So what I'm trying to do is I'm trying to add it to the wall of the beaker so that it flows in and forms a layer on the top. It's a bit tricky. This is the third one. For some strange reason it just seems to be jamming, but I'll try to continue. I don't quite want to come out this one. This is the 4th one. I think I might have picked the wrong syringe here, so quite tricky this one. No cap on it, so I haven't made a silly mistake. And this is the 5th one. Okay, so in goes the last one. Upon consultation with our lab technician, I completely agree that it's going to be safer to actually do the rope part within the fume cupboard. And I was just wondering whether we could get enough light on it, but I'm feeling very confident about this. And you'll see that there is a slight film that's formed over here, and I'm going to use these tweezers to pinch that film, and that film is your nylon. So the reaction takes place between the 2 layers. I'll give you a chance to zoom in completely as I drag out this film. So I'm going to slowly pull it. You have to be very, very careful at this stage because these globules are absolutely jam-packed with hydrogen chloride, and that can easily form concentrated hydrochloric acid, I should say. But here we have our rope now fully formed, and all we need to do is wind the rope, and we have our nylon. This is nylon 610. So what I'm now going to do is I'm just going to slowly wind the rope along the rod, and I should be able to get roughly maybe around about a meter's worth. And this is the nylon that's actually used for clothing, for ropes. If anyone fancies bungee jumping, parachuting, all the extreme sports, I find it's absolutely amazing that 2 liquids come together and form a solid, and this is like your polymer. Does anyone want to have a chance to roll it?
Without our gloves?
Oh, with gloves.
So we tested for chloride ion. We add silver nitrates, then what do we do? If we get a precipitate, what do we do after that?
So here we have our nylon. So the reason why we rinse it is to try and get rid of as much of the HCl as possible. So we use the hydrogen chloride. We want to try and get rid of the hydrogen chloride. So what we do is we rinse it in distilled water. At this stage, I'm quite comfortable just squeezing everything into the water and giving it a rinse. And then I'm going to give the six formers who've been diligently helping me with the production a chance to handle it using their gloves. So at this stage, it should be okay to handle. And that's it. That's our nylon.
It smells weird.
Oh, if it smells weird, dip it back in. Okay, in fact, should we go outside?
Yeah.
Yeah, let's go outside and start again. There we go.
So can it tear like easily?
It will tear with but the fact that it's binding together is shows that you've linked the molecules together. Why are you thinking of keeping a piece? Would you like one?
So do you do this with the other class?
No, because unfortunately we're very, very limited with. This is a very expensive set of reagents.
Really? How much?
Too expensive to show them.
Want me to keep it over the beaker, yeah?
Yeah, but we can string it out, like literally.
So in your video you should mention how it can't work. So that
Can someone record?
Yeah. I will do.
Can you record?
Awesome. My hands are...
Oh yeah.
I'll say that our first run.
So you know what the first thing I thought of? This is how Spider-Man makes his webs.
It does look
Yeah,
nice.
it does look expensive. Just rinse it in there. Just pop it in the water. Just keep it all in there, just to make sure that I'm not breathing the organic stuff.
So how do they do this in factories with their things like
It's a really, really interesting question. So what they must have machines that pick out how once it starts, all they need to do, I would guess, is just keep injecting liquid at that interface, just draw it.
And so when does it become safe?
I suppose if it's constantly rinsed and
But imagine like if Spider-Man
But
made
this is a small amount. Like,
it's
not
really
that-
small amounts
yeah.
now, and it's already reacted as well. So
But imagine if Spider-Man made this, he has chloride up in his veins up here. So
yeah. Do you think this could be like how Spider-Man makes?
Yeah, but only Tobey Maguire is the only
Tobey
one.
Maguire has it in his skin.
Yeah.
Other ones have to make it manually.
No, that's the shooters. No.
Before he goes, he first puts the...
Would you like a piece each?
No,
Sure.
I'm fine, sir.
Yeah, a little bit. Alright, I need to find the end. So that's fine.
It smells
There
weird.
we go. Don't smell your hands. Don't smell your hands. Not very good. Sorry. Oh, that's probably too small. So, how about how much? There we go.
No, thank you, sir. It's fine. I already have nylon.
Okay, just get a zoom in on this. Isn't it amazing? And it does have like that elasticity to it. Yeah?
It's very flexible, sir.
Very flexible. Very flexible. And can you imagine working with different monomers for a polymer company? You can imagine that.
What was the woman's name again, sir?
Oh, it's her name, Stephanie Pollock. Yeah. So this is what she did. It's basically she did this, and then she managed to change the world.
Did you get any money from that?
Oh yeah, trust me. want another piece?
No, it's
Yeah.
someone will pick up that line.
No, no, no. Put it in the bin. Otherwise, the birds will have it.
Oh.
Amazing. Cool. Should we go back to class?